Welcome back for day 13 on Advent of Code. Today we have a distress signal and some decoding of these packet things that they're called. So this is our input. We've got pairs of arrays and arrays of arrays with numbers or arrays inside them, and it gives us some rules on how to compare those. The question for part one, it also gives us a lot of examples again, which is definitely helpful. The question for part one is determine which pairs of packets are already in the right order, and then to return the sum of the indices of those pairs. Let's hop into the code. All right, just starting out here, I've got the read file synchronous function from the file system library. I'm using that to read in the input. Here's what my input looks like. And the way I'm going to read that input is I'm going to define this variable called pairs, and I take file.trim.split on the double new line character, so it'll return me the pairs, and then I'm going to parse those pairs and do some logic with them. So let's hop into what exactly that logic is. We want a function that takes in a list, a value, or packet and returns something. In this case, we're going to return 1 if a is less than b, 0 if a equals b, and -1 if a is greater than b. So I'm going to go ahead and define our compare function right from the get-go using those rules that were given to us from the problem statement. So this function compare packets, it takes in two parameters. They're both of the same type, which is they're going to be an array of numbers or a number itself. This is going to be a recursive function, so we need it to be able to take either one of these. We're going to call this function on it within itself. And that's all I really think I need to say about the function definition. Inside the function, here's how we're going to work our logic. First, we're going to handle type mismatches. So this is when we send to compare packets. If we send it on, say, A is an array of numbers, but B is a number or something like that. Then we want to make sure that we're comparing apples to apples in this case. And that's what we're going to do with the handle type mismatches section. Next, we'll define our base case, which is the easy one where we just compare integers. Is 5 less than 7? Yes, it is. That would return true. Are they equal, or is it the other way around? And then we have our recursive case where we're comparing our arrays. We want to go into that array and compare from there. So let's handle the type mismatches for right now. So all we need to do is check if A is an array and type of B is number, then all we want to do is wrap B in an array just like that. And we're going to do the same thing, but switch to this time. So we'll wrap A into an array. Now, let's try to compare integers. If they're both of type number, then what we want to do is if A is less than B, we return 1. Else, if A equals B, then we'll return 0. And in the last case, we'll return -1. So that's kind of an easy base case. But now we need to handle the more challenging case, which is our recursive case where we compare arrays. So we should know by now that both of them are arrays, but to satisfy some Typescript, I put that they are both arrays. So if A is an array and B is an array, then we'll descend into this conditional logic. We'll let I equal 0. This is an index that we're going to define. And while that's less than a.length and less than b.length, then we'll define this function, sorry, not a function, we will define this variable called result, and we're going to compare packets of the ith element in A and the ith element in B. After that, we'll say if result is equal to 1, then we return 1. Otherwise, if it's -1, we return -1. Pretty simple here. And then we will increment I. And now we're going to check that if A runs out of elements before B does, so we're going to break from this while loop if A is less than B. Sorry, A.length is less than B. Then we're good. So here we know that I is equal to A.length, and then we'll check if A.length is equal to B.length, then we return 0. Otherwise, we're going to turn 1, which is a good case that they are in order. The left side packet A was smaller. And we need to handle that for B as well. We'll return -1 when B.length is less than A.length. So now we can go ahead and get into actually getting the solution. I'm going to define a variable called result, set that equal to 0. And then I'm going to go through each pair of the input. So remember up here, this pair that I have, I think that was from up here. Yep. So I'm going to go for each pair in pairs, I'm just doing some parsing right now. I'm going to use the eval function in JavaScript and match each packet from string to JavaScript syntax. So this is just an easy way of taking that string from the input of all this stuff, and rather than it being a string when we read the file in, it actually makes this an array. It makes this whole outer thing an array. It makes these numbers. Eval is great for that. There's a lot of reasons when you don't want to use eval if you have like a public facing whatever, if this code is going into production, that people can take advantage of using eval. But in this case, we're just trying to find the answer to a problem. Okay, so now we've got this packet A and packet B. So packet A is going to be this whole line, and packet B is going to be this whole line. And we're going to use those as parameters to our compare packets function. If we get it equal to 1, then we want to add to 1, and they're also 1 indexed. So we're going to take the index, add 1, and add that to result. And then at the end, we're just going to console log result. So if I go ahead and save, and I run this, we get 6,046. Check our answer. 6,046 is the right answer. For part 2, now it wants us to sort all of these arrays, and it wants us to insert this double array 2 and this double array 6 at the right points. And really all we're going to do is we're going to use the JavaScript sort function to sort everything. And then we're going to push these in before that, and they're going to get sorted along with everything. Because I think the question wants us to organize all the packets in the correct order. What is the decoder key for the distress signal? And to get the decoder key for this signal, we determine the indices of the 2 divider packets and multiply them together. So we'll get the index of this one and the index of this one and multiply those. Puzzle answer is 21,423. Let's see if we can get there. All right, get rid of the terminal. Part 2. So let's define an array to put packets into, which we will sort later. So this is kind of our result array. It's just going to be an empty array for now. And then we'll go through that pairs again that we got all the way up here. And for each, and for part 1, we did the same for each loop, but we compared packets for each pair. This time we're just going to add them to the array. You'll see what I mean. So we will let split pair equal pair.split, and we'll use eval again to map those, match those packets into packet A and packet B. And rather than comparing packets, we're just going to push them into the array. So array.push packet A, array.push packet B. And we also want to push these index tracking double arrays in as well. Now, the last thing we're going to do is call that sort function, but the sort function we're going to pass our compare packets function. So array.sort, sort can take we can define in JavaScript any sort of way that we want this sort function to work. So all we have to do is pass it a reference to our compare packets function, and it'll use that. And then I had to reverse it just because I had to reverse it for whatever reason. So I guess, if I didn't want to reverse it, I would have had to flip how this sorts up here. But that's the way it happens. And I'm going to define index of 2 and index of 6 just as these null indexes right now, but we're going to find them. And to find them, I've got to go through the result array and check for them. So if packet.toString equals 2, and since I have to check for the string value because I can't check for arrays because these are passed by reference. So that's why we're looping through like this. We'll get index of 2, and we're adding 1 because these are 1 indexed per the problem statement. So now we have index of 2, index of 6, and we need to multiply them together to get our answer. Let's have a look. Let me save. Okay, so 111 is index of 2, and 193 is index of 6. 21,423. We have got the right answer for part 2 on day 13. Thank you for watching. It really helps out the channel if you subscribe. So please consider subscribing, and I will see you for day 14. Bye-bye.
Yeah.